भौमिक जी
Sir, good morning, sir. Jai
गुड
Shri.
मॉर्निंग नमस्कार
Sir, most welcome, sir. Swagata, over to you. Swagata, over to you.
Good morning to all the respected delegates present over here. First of all, we would like to wish everyone a very happy World Pharmacist Day. And the theme for this year is Pharmacist Strengthening Health System. Today we have with us an eminent professor, Dr. R.K Maheshwari Sir, who will be enlightening us on hydrotropy, mixed hydrotropy, and mixed solvency technique. First of all, I would like to thank our respected principal, Dr. Mithun Bhomik Sir, our HOD ma'am, Dr. Pratibha Bhomik, for providing us this wonderful opportunity on this special occasion. I would like to hand over the podium now to our Mithun Bhomik Sir for his enlightening words.
Good. Thank you, Swagata. Good, good morning, esteemed guests, faculty members, dear students, and all participants. First of all, I want to wish you all a very happy World Pharmacist Day. Today, we gather here to celebrate the invaluable contribution made by the pharmacists around the world and to delve into the fascinating world of pharmaceutical research and innovation. I am delighted to welcome our distinguished guest, Dr. R.K Maheshwari, an eminent personality in the field of pharmacy. Dr. Maheshwari is an ex-professor and head of the pharmacy department at SGSITS Indore. His expertise and knowledge have been instrumental in shaping the future of pharmacy education and research. Today, we have privilege of attending a webinar presented by Dr. Maheshwari Sir on the topic hydrotrophy, mixed solvency technique, concept of the future to replace harmful organic solvents with solids. This topic holds immense significance in the current era where sustainability and environment consciousness are at the forefront of scientific advancement. Thank you, and I wish you all a fruitful and inspiring session ahead. Over to you. Swagata, over to you.
Thank you, sir, for your inspiring words. Introducing our eminent speaker, Dr. R.K. Maheshwari is a renowned expert in the field of pharmaceutical sciences with an impressive track record of achievements and contributions to research and academics. With an extensive experience and knowledge in the area of pharmacy, he has been actively involved in guiding MPharm projects with over 75 successful projects under his mentorship. His academic progress extends further as he has guided and supervised multiple PhD students. In terms of research, Dr. Maheshwari's outstanding work is evident through the publication of more than 200 research papers in reputed journals. Additionally, he has presented more than 150 research papers at various conferences and academic platforms, displaying his ability to disseminate and share scientific knowledge with his peers. Dr. Maheshwari's Dr. Maheshwari's excellence in the field has been recognized and acknowledged through various esteemed awards. Notably, he has received the prestigious Lifetime Achievement Award 2021, Pharmacy Recognition Award 2021, Eminent Researcher Award 2012, and Best Research Award 2005, among many others. Furthermore, Dr. Maheshwari is an accomplished speaker and has delivered expert lecture on numerous occasions. His expertise and ability to communicate complex ideas in a simplified manner make him an engaging and sought after lecturer in the field. Overall, Dr. Maheshwari's remarkable contributions, research achievements, and dedication to his students and the field of pharmacy make him a highly respected and influential figure. With his wealth of knowledge and experience, he continues to inspire and shape the future of pharmaceutical sciences. I would now like to invite Dr. R.K. Maheshwari for his enlightening words and speech. Over to you, sir.
Okay, good morning to all of you. Firstly, I would like to thank Dr. Mithun Bhomik, who has given this chance to me to share the new research ideas for the pharmacy students and teachers. As you know, today is the World's Pharmacist Day. So I congratulate all of you on this event. And now I shall start my lecture. And let me explain you firstly that what shall you get in my lecture, what new research ideas you will get in my lecture. You will find that we can utilize the solubilizing power of solids, which are economic as well as they are harmless to our health. And we will utilize the solubilizing power of solids to replace harmful organic solvents. During the lecture, so many questions may arise in your minds. So please note down your questions. At the end of the lecture, we will have question answer session. Okay. Briefly, let me explain you up to this time. From the books, from the literature, what we know that whatever are the substances available in the form of liquids at room temperature, they all are known as solvents. For example, water, ethanol, methanol, chloroform, etc. So such substances which are in liquid state at room temperature, they are known as solvents. Okay, but there is no universal solvent. Whatever the name of any solvent we take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes, although they are all are known as solvents. For example, we know from the books, from the literature, that about 1/3 of the total drugs they are water soluble, and about 2/3 of the drugs they are water insoluble. So what can we say? That water is good solvent for some drugs, 1/3 drugs. Water is bad solvent for 2/3 drugs, like this. So whether you take the name of chloroform, methanol, DMF, DMSO, etc., the same statement will be applicable for all the so-called solvents. Means whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. This statement will be utilized in my lecture because I have started a very new concept known as mixed solvency concept. Mixed solvency concept in the year 2009. And there are two parameters of this concept. Number one parameter says that each and everything present in this universe has got solubilizing power. Each and everything means whether the substance is gas, whether the substance is liquid, whether the substance is solid. So in other words, we may say all the molecules which are present in this universe, they have got solubilizing power. But now there will be, you should know that how the gases will possess solubilizing power or demonstrate their solubilizing power when the molecules of gas are in liquid state. And in the same cases with the solids also, when the solid molecules will be in liquid state, then of course they can demonstrate their solubilizing power. So before explaining all these things, let me first clarify the mechanism of dissolution. A simple mechanism of dissolution. Actually, dissolution takes place due to hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. For example, suppose you dissolve ibuprofen in ethanol, you will get a clear solution of ibuprofen in ethanol. Why? As a result of hydrogen bonding and weak van der Waals forces between the molecules of ibuprofen and molecules of ethanol. If you are dissolving, say for example, mannitol in water, you get a clear solution. Why you are getting a clear solution? As a result of hydrogen bonding and weak van der Waals forces between the molecules of mannitol and molecules of water. So simple, this mechanism is there for dissolution. Now I will give the example of gases. How can you say that gases also possess solubilizing power? Because it is not there in my PowerPoint presentation. So let me explain verbally that thing. Means we have to prove that how can we say that gases possess solubilizing power? You see a supercritical flow technology which is running in our universe. You know, supercritical flow technology in which liquefied CO2 gas, liquefied CO2 gas is used as solvent to carry out different functions like preparation of nanoparticles by supercritical fluid technology, extraction of active constituents from herbal powders using supercritical fluid technology, and so on and so forth. So ultimately, a gas means CO2 after liquefaction is acting as solvent. But that is also not good solvent for each and everything. Which one? Carbon dioxide, liquefied carbon dioxide. Because sometimes for such solutes or you may say the constituents which are poorly soluble in liquefied CO2, we have to imply co-solvents like methanol, ethanol, etc. So you may say that liquefied CO2 is good solvent for some compounds. In those cases where you do not use a co-solvent like ethanol, methanol, etc. And liquefied CO2 is bad solvent for those compounds in which you have to utilize co-solvents in supercritical fluid technology like ethanol, methanol, etc. So anyway, now why it is demonstrating its solubilizing power? The reason is same, that in liquefied conditions, CO2 molecules, means gas molecules, they are in liquid state. And these CO2 molecules are involved in hydrogen bonding at weak van der Waals forces with the molecules of solutes. Okay, so this means number one way by which the molecules of a gas may come in liquid state is by liquefaction. If you liquefy any gas, nitrogen, oxygen, helium, any gas, that will also be good solvent for some compounds and bad solvent for other compounds, as was the case with the so-called solvents. Another way by which the molecules of a gas may come in liquid state is by dissolution in a solvent. For example, concentrated hydrochloric acid, we know, concentrated hydrochloric acid, which contains about 38% weight by volume of, weight by weight, you may say, of dissolved HCl gas, HCl gas. 38% weight by weight means 100 grams of concentrated HCl contains about 30 grams of dissolved HCl. So in this dissolved condition, the molecules of HCl, they are in liquid state. And now I am giving one example of a drug, nalidixic acid. Nalidixic acid is a poorly water-soluble drug, but in concentrated hydrochloric acid, the solubility of nalidixic acid is more than 5%, more than 5%. Why it is so? The reason is same, the molecules of HCl are in liquid state, and these molecules of HCl, they are taking part in hydrogen bonding and weak van der Waals forces with the molecules of nalidixic acid. That's why there is a large solubility of nalidixic acid in concentrated HCl. Although we are not talking about the formulation, we are just seeing the proof that how can we say that gases also possess solubilizing power. Anyway, if we utilize the solubilizing power of gases for solubility enhancement, it is a costlier affair. So we are keeping these aside. Mostly, I will focus in my lecture on the utilization of solubilizing power of safe and economic solids. So now I am going to present my PowerPoint presentation, okay, and then I will explain you all these things. Visible? Yes. Okay. So now, of course, the today's topic, as you has been mentioned in this event of World Pharmacist Day, was hydrotropy, mixed hydrotropy, and mixed solvency concepts of the future to replace harmful organic solvents with solids. And this topic, as is before you, is also more or less same. Solubilizing properties of solids shall replace harmful organic solvents. Okay. Now let us understand about these organic solvents, where they are involved. So various organic solvents are employed in various analytical techniques like TLC, HPTLC, HPLC, UV spectrophotometric analysis, titanimetric analysis, etc. Also, organic solvents are involved in the extraction of active constituents from herbal powders. Also, organic solvents are involved in the synthesis of organic compounds. Also, they are involved in formulation of pharmaceutical dosage forms, etc. Now, we want to replace harmful organic solvents. Why? What is the reason? Why do we want to replace them? So now you see the drawbacks of organic solvents. They are very injurious to our health. Organic solvents have innumerous adverse effects caused by single exposure like dermatitis, headache, drowsiness, nausea, irritation, etc. What is this single exposure? This is means suppose you are performing any analysis means in practical lab. So means just once. Suppose you are utilizing methanol or DMF, etc. or chloroform. So what will happen? There may be headache, nausea, eye irritation, but these are reversible processes. They are not very harmful for us. But now you see the next point. Long-term exposure causes serious ill effects such as neurological disorders, chronic renal failure, liver damage, neurosis, mutagenesis disorder, etc., etc. What is this long-term exposure? When human beings, they are involved constantly in companies, suppose they are involved in the analysis, so daily they are going to use the HPLC analysis and all that, in which there is methanol, acetonitrile, etc. So means you may think in this way that the human being serving an analytical department may be exposed you understand is daily with the fumes of volatile organic solvent. So these serious ill effects may be there for that human being. Now the lecture means the objective of today's lecture is that can we prevent human being against harmful effects of such organic solvent? So yes, we are trying. I am trying to explain these things to you so that in future we can minimize the use of harmful organic solvents in various operations, for example, in analysis, formulation, synthesis, etc., etc., like this. Not only organic solvents are injurious to our health, but they are also costly. And one more drawback of them, when they are disposed of from the companies after their use, from big companies and all that, they are supposed to be given a particular treatment to make them safe before they are thrown away. So another cost involving factor. So they themselves are costly and their disposal is also costlier. Anyway, now there are three classes of organic solvents. So the students should understand three classes of organic solvent: class 1, class 2, and class 3. Class 1 organic solvents, they are very harmful for human being. Benzene is carcinogenic. Carbon tetrachloride toxic, and it causes environmental hazard. Means how this harm is there, I have explained to you. When a person is involved in with the use of benzene in some of the operations, then because they are volatile, they go in our body and they for example, benzene may be carcinogenic to human being like this. So we will try to minimize the use of such organic solvent. Class 2 organic solvents, they are relatively safer than class 1 organic solvent, but then also they are very harmful for human being. Commonly employed class 2 organic solvents, they are acetonitrile, chloroform, toluene, methanol, pyridine, hexane, dimethylformide, etc., etc. Class 3 organic solvents, out of these three classes, 1, 2, 3, these are quite safer, but then also they are harmful. Commonly employed class 3 organic solvents, they are acetic acid, acetone, ethanol, ethyl acetate. Okay. Now, sometimes due to less solubility in class 3 organic solvents, we are forcefully, or you may say, we have to utilize class 2 or class 1 organic solvent, which are better, which have better solvency character. So I will tell you that you can potentiate the solvent power of a class 3 organic solvent to act as class 2 or class 1 organic solvent, so that you can reduce the harmful effect of organic solvent for human being. So these examples I will give in my lecture, that how can you potentiate a class 3 organic solvent like ethanol to act as chloroform or dimethylformamide or carbon tetrachloride, so on and so forth. I will explain in my lecture further. Now, future role of solvent character of solids. Solubilizing power of solids shall minimize the use of harmful organic solvents in future. Class 3 organic solvents are relatively safer than class 2 and class 1 organic solvents. We can potentiate the solvent power of class 3 organic solvents by dissolving safe solids in them to replace class 2 and class 1 organic solvents. Dissolution, again I am explaining this thing. Dissolution of a solute in a solvent involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. Mixed solvency concept proposed by me in the year 2009 states that each and every substance, whether the substance is gas, whether the substance is liquid, whether the substance is solid, present in this universe has got solubilizing power. Once the molecules of a gas or molecules of a solid come in liquid state, they may also be involved in hydrogen bonding and weak van der Waals forces with the molecules of solute for the dissolution of that solute. Whatever matter exists in liquid state at room temperature is known as solvent. Each liquid or so-called solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similarly, each matter, whether matter is liquid, gas or solid, is known as solubilizer in mixed solvency concept. Molecules of all solids in liquid state and molecules of all gases in liquid state also possess good solubilizing power for some solutes and bad solubilizing power for other solutes. Now I will give the proof. Firstly, I will give the proof that how can we say that solids possess solubilizing power, and then afterwards I will give the you may say the application part of these solubilizing power of solids, that how can we minimize the organic solvents. So during the proof, when I will proof, please do not relate with formulations. Okay, so now I have told you that the molecules of a solid may come in liquid state by three ways. Number one, by melting. Number two, by dissolution in a solvent. Number three, by eutectic formation. Once the molecules of solid come in liquid state, the molecules of solid can be involved in hydrogen bonding, weak van der Waals forces with the molecules of solute for their dissolution. So one by one we will discuss. Number one, by melting, means how the molecules of a solid may come in liquid state. Number one way is melting. So there are two examples of melting. Number one example says that melted urea. If you take in your test tube 1 gram urea crystals, 1 gram in your test tube, you keep it on heating mantle. The melting point of urea is 132 degrees centigrade. So you will get a clear colorless liquid at 132 degrees centigrade, means clear colorless melted urea liquid, which can be taken like any solvent. Okay. In this 1 gram melted clear colorless urea liquid, 1 gram of dichlorofenac sodium is nicely dissolved. You get a clear solution at 132 degrees centigrade. The melting point of dichlorofenac sodium is 283 degrees centigrade, 283 degrees centigrade. And here the temperature of melted urea is 132. So this indicates that dichlorofenac sodium is not melted at 132 degrees centigrade. This means dichlorofenac sodium gets dissolved in melted urea at 132 degrees centigrade. Now, why you are getting a clear solution? This shows that urea has got solubilizing power for dichlorofenac sodium. Suppose urea was not having solubilizing power for dichlorofenac sodium, then you could have obtained a suspension of dichlorofenac sodium. But you are getting a solution. This means melted urea is good solvent for dichlorofenac sodium. Now, the reason for dissolution, the molecules of urea, they have come in liquid state and melted urea. And now these molecules of urea are involved in hydrogen bonding and weak van der Waals forces with the molecules of dichlorofenac sodium. And that's why we get a solution of dichlorofenac sodium. We are not talking about the formulation, but we are saying a proof that melted urea has got good solubilizing power for dichlorofenac sodium. Another proof. Now, phenol. Phenol is also solid at room temperature. Its melting point is 44 degrees centigrade. In your test tube, if you take 1 gram phenol, if you dip this test tube in water bath at about 44 degrees centigrade, which is the melting point of phenol, you will get a clear colorless melted phenol liquid 1 gram, which can be taken like liquid. And in this 1 gram melted clear colorless phenol liquid, 500 milligram of nalidixic acid is nicely dissolved. Means very good solubility of nalidixic acid in melted phenol liquid. Means about 40-50% solubility, means very high solubility. Why? Otherwise, nalidixic acid is a poorly water soluble drug, and its melting point is 230. It does not get melted. No, it does not melt at 44 degrees centigrade. This means it is being dissolved by melted phenol liquid. And I told you that the solubility of nalidixic acid in water is very poor. But here, a very high solubility. The reason is the molecules of phenol are in liquid state, and these molecules of phenol, they take part in hydrogen bonding and weak van der Waals forces with the molecules of nalidixic acid to dissolve it. So, these are two proofs that by melting the molecules of solid may come in liquid state. And one more thing you should understand, means it is not required that always you will melt the solid to dissolve the no. There are other ways. So, firstly, you understand the proof, see the proof that solids have got solubilizing power. Then we will discuss about the application part of solids. Mostly we shall utilize solutions of solids. Now, another way by which the molecules of a solid may come in liquid state is by dissolution in a solvent. Molecules of a solid may come in liquid state when the solid is dissolved in a solvent. Three examples of solvent. Number one is that of water. In water, the solubility of ibuprofen at room temperature is very poor, 0.028%. Why there is poor solubility of ibuprofen in water? The reason is the limited extent of hydrogen bonding at weak van der Waals forces between the molecules of ibuprofen and one molecules of water. That's why there is poor solubility of ibuprofen in water. Okay, very poor solubility, weight by weight, 0.028% weight by volume. Solubility of ibuprofen in 2 molar sodium benzoate solution. 2 molar means 28.8% weight by volume solution of sodium benzoate in water. The solubility is 2.390% weight by volume. So how many fold solubility enhancement is there? 2.390 divided by 0.028 means about 85 fold solubility enhancement is there. 85 times solubility enhancement is there. What is the reason for solubility enhancement? The reason is in this concentrated solution of sodium benzoate, the molecules of sodium benzoate, they are in liquid state, and these molecules of sodium benzoate take part in hydrogen bonding at weak van der Waals forces with the molecules of ibuprofen or its dissolution. That's why the large solubility is there. Of course, this is an example of hydrotropy solubilization, but what we are seeing, observing here is solid means sodium benzoate, and molecules come in liquid state by dissolution, then these molecules demonstrate their solubilizing power. Now, another example is that of ethanol solvent. The solubility of furosemide in ethanol is very poor, 1.7% weight by volume. Means poor solubility, sparingly soluble. It is sparingly soluble. Again, the reason is due to limited extent of hydrogen bonding and all that between ethanol molecules and furosemide molecules. But when we prepare a 15% weight by volume solution of niacinamide in ethanol, 15% weight by volume solution of niacinamide in ethanol, the solubility of furosemide in this solution system is about 5% at room temperature, 5%. 5 divided by 1.73 fold enhancement, 3 times solubility enhancement is there. What is the reason for this? The reason is the molecules of niacinamide, which is solid at room temperature, its melting point is 132 degrees centigrade. No need to discuss about this, but what I want to say that niacinamide, when it is dissolved in ethanol, the molecules of niacinamide come in liquid state, and these molecules of niacinamide, they take part in hydrogen bonding and weak van der Waals forces with the molecules of furosemide to dissolve it. That's why the solubility has been increased. Of course, we are not talking about the formulation at this time. The third example is that of propylene glycol solvent. There is poor solubility of pyroxychem in propylene glycol, about 5 milligram per ml, about 5 milligram per ml. Solubility of pyroxychem in a solution containing 10% sodium acetate and 10% sodium caprylate and propylene glycol is about 120 milligram. Means what you are doing, you are making a solution of two solids, 10% sodium acetate, 10% sodium caprylate, 10% in propylene glycol. So total strength is 10 plus 10 is 20%. Strength is there of this solution, and in this particular solvent system, the solubility of pyroxychem is about 120 milligram per ml. So 120 divided by 5, about 24-fold enhancement in solubility is there. Why? Of course, we are not talking about the formulation, but we are seeing that by dissolution of two solids is helping to increase the solubility of pyroxychem in propylene glycol. The reason is for solubility enhancement is the molecules of sodium acetate and molecules of sodium caprylate they are there in liquid state, and these molecules are involved in hydrogen bonding and weak van der Waals forces with the molecules of pyroxenium for enhanced solubility. Okay, so these were the proof that by dissolution in a solvent, the molecules come in a liquid state and they can demonstrate their solubilizing power. Third way by which the molecules of a solid may come in liquid state is by eutectic formation. If you take 5 gram thymol, 5 gram menthol, triturate with the help of pistol mortar, you get a clear colorless eutectic liquid of these two solids. Clear colorless liquid, just like water, transparent. Now, it's a pH is 6.5, means nearly neutral. Okay, now the properties of this eutectic liquid, if you take 1 ml of this eutectic liquid in your test tube, it dissolves more than 200 milligram of metronidazole benzoate. Clear solution you get. Otherwise, this metronidazole benzoate is a poorly water soluble drug. But here, the solubility is about 20%. Why? Of course, we are not talking about the formulation, but we are seeing that there is very good solubility of metronidazole benzoate in this eutectic liquid. What is the reason for this? The reason is eutectic liquid contains molecules of thymol, molecules of menthol, and these molecules are involved in hydrogen bonding and weak van der Waals forces with the molecules of metronidazole benzoate, and that's why we get a very good solubility of metronidazole benzoate in this particular eutectic liquid. Similarly, this eutectic liquid is good solvent for atenolol, arnitazole, benzocaine, utrazate, etc., etc. But if you see other column, right-hand column, 1 ml of this eutectic liquid does not dissolve even 5, as a small quantity as 5 milligram of cetronidazole. This means this eutectic liquid is poor solvent for cetronidazole. Similarly, this eutectic liquid is poor solvent for fusamide, nimesulide, aspartame, etc., etc. Now, if you want to see the solubility of some liquids in this eutectic liquid, so ethanol, propylene glycol, benzyl alcohol, etc., they have got very good solubility, or in other words, you may say good miscibility in this eutectic liquid, but glycerin is immiscible in this eutectic liquid or insoluble in this liquid. Water is insoluble in this liquid or immiscible in this liquid. Similarly, if you check hundreds of compounds for solubility in eutectic liquid, some new compounds, some will fall in this column, some will fall in this column. So you may say now this eutectic liquid is good solvent for some compounds, bad solvent for other compounds. Now, just like the so-called solvent, now you can say this eutectic liquid is a solvent. Once you say it is a solvent, this means whatever it contains must possess solubilizing power. So it contains two solids. The molecules of two solids, they are in liquid state, thymol and menthol. And that's why thymol and menthol must possess solubilizing power. That's why you are having very good solubility of some of the compounds and so on and so forth. So this is a proof, again, that solids possess solubilizing power. Now coming directly to the hydrotropic solubilization. Hydrotropic solubilization is more than 100 years old concept. More than 100 years old concept. Hydrotropic solubilization. Firstly, I would like to give a few examples of hydrotropic solubilization. You see in the middle, urea. These all, whatever you are seeing on your screen, they all are examples of hydrotropic agent. Of course, these are some of the hydrotropic agent, but still the list is vast. Now, the solubility of dichlorofonic sodium in water at room temperature is 1.6%. 1.6% weight by volume solubility of dichlorofonic sodium in water at room temperature. But if you check the solubility of dichlorofonic sodium in a concentrated solution of urea, 60% weight by volume solution of urea. How will you make this 60% weight by volume solution of urea in water? You will take 100 ml of the volumetric flask. From the point of view of students, I am explaining 100 ml of volumetric flask, 60 gram of urea, sufficient water, shaking for dissolution. When you get clear solution, make up the volume up to 100 ml with water. You are having 60% weight by volume solution of urea in water. In this concentrated solution of urea, the solubility of dichlorofonic sodium is about 4.8%, 4.8. In water, 1.6. So 4.8 divided by 1.6, threefold enhancement in solubility is there. Threefold enhancement in solubility. The reason for this solubility enhancement is Again, the same that urea molecules, they are in liquid state in aqueous solution. And these molecules of urea, they take part in hydrogen bonding and weak van der Waals forces with the molecules of dichlorofluoride sodium to increase its solubility. Same reason is there. Okay. Another example, salicylic acid is a poorly water-soluble drug. Its solubility means solubility of salicylic acid in water at room temperature is 0.3% weight by volume, nearly 0.3%. But if we prepare a 45% weight by volume solution of sodium citrate in water, a concentrated solution of sodium citrate in water, in this solution, the solubility of salicylic acid is more than 15% weight by volume. So 15 divided by 0.3, about 50-fold enhancement in solubility is there. What is the reason for solubility enhancement? The reason is that molecules of sodium citrate, they are in liquid state and these molecules take part in hydrogen bonding, etc. Like this. The same case. Okay, similar. Now, a third example of hydrotrophic is in sodium benzoate. If you prepare, say, 30% weight by volume solution of sodium benzoate in water, a concentrated solution, in this hydrotrophic solution of sodium benzoate, the solubility of several poorly water-soluble drugs is enhanced. For example, that of ofloxacin, catifloxacin, tinidazole, metronidazole, norfloxacin, then your this ibuprofen, flurbiprofen, naproxen, nalidixic acid, hydrochlorothiazide, and so on and so forth. A large number of poorly water-soluble drugs have got very good solubility in concentrated solution of sodium benzoate. So these are other examples of hydrotrophic solubilization. Now here, now you see why it is known as hydrotrophic solubilization. The reason is hydro means water. So in all these cases, you find that there is solubility enhancement in aqueous solution or in water. So that's why Newberg, etc., they have put this word hydrotrophic solubilization, 100 years old. In 1916, Newberg, etc., they have started this term hydrotrophic solubilization. Okay. Now I'm giving the definition of this 100 years old concept. When there is enhancement in aqueous solubility of a poorly water-soluble drug in the presence of a large concentration of an agent, means hydrotrophic agent, then we call this phenomena to be hydrotrophic solubilization phenomena. Again, I am repeating, aqueous, there are two important things, aqueous solubility enhancement and concentrated solution of hydrotrophic agent. So when there is enhancement in aqueous solubility of a poorly water-soluble drug in the presence of a large concentration of an agent, then we call this phenomena to be hydrotrophic solubilization phenomena. So this is 100 years old concept. But when I started my PhD work from the 2004 year 2004, I have started its application in various fields and analysis and so on and so forth, so that we can minimize the use of harmful organic solvents. Now you see, these are other examples here, but since time is limited, so I cannot explain each and everything here. But one thing I can say that at the end of the lecture, I will give my WhatsApp number and email ID. Those who are interested to have this particular PowerPoint presentation, to have large number of examples, they can ask me, I can send it to them, whether you are a student or teacher or any researcher. Now coming to the application part of this 100 years old concept, hydrotrophic solubilization. Eco-friendly titematic analysis of poorly water-soluble drugs using hydrotrophic solution without using organic solvent. Now you see here, IP, Indian Pharmacopoeia, British Pharmacopoeia method, recent, latest method in Pharmacopoeia, assay of furosemide API. API means active pharmaceutical ingredient, means bulk drug, in other words you say. So when the bulk drugs, they are used for making tablet injection, etc., they are checked for their purity, means how much percent of furosemide pure is present in your API. So for this, these APIs, they are assayed. So now the procedure is weigh accurately about 0.5 gram furosemide API, dissolve in 40 ml of dimethyl formamide in a conical flask. You will get a clear solution. Then few drops of bromothiamyl blue solution indicator is added, and titration is performed with 0.1 molar in your solution. At the end point, suppose the volume consumed, that of NaOH, is x1 ml. Please suppose x1 ml of NaOH 0.1 normal has been consumed. This is first titration at end point. So we have noted this. Then we have to carry out a blank determination. Blank determination will be taken, done like this. You will take another neat and clean conical flask. You will take 40 ml of dimethyl formamide in that, few drops of bromothymol blue indicator will be added, and 0.1 molar NaOH will be utilized for titration. Very few ml of NaOH will be required to get the end point. Suppose that is means half ml, 1 ml are like that. Suppose we say that it is Y1 ml. So Y1 ml has been consumed by 40 ml of dimethyl formamide. This means the same Y1 ml might have been consumed in this previous titration also. So this much volume of NaOH is required for your drug. Then using the factor as given in the last, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of fusamide. You can find out the drug content. So what is the beauty of this method? The beauty is that you are utilizing dimethyl formamide. Pharmacopoeia, they are using dimethyl formamide, which is a class 2 organic solvent. Of course, it is harmful. Okay, whenever you will perform such titration, dimethyl formamide vapors will go in your body. It is harmful for you. Okay, now why they have selected dimethyl formamide? Why not water? Because in water, it is nearly insoluble, furosemide, so water cannot be taken for titematic analysis. Then why they have not employed ethanol? Ethanol is a class 3 organic solvent. Dimethyl formamide class 2, more harmful than ethanol. But why the pharmacopoeia persons, they could not employ ethanol? The reason is, in ethanol, the solubility of furosemide is poor, sparingly soluble. That's why they could not employ a safer class 3 organic solvent, but due to, you may say, the solubility reason, they are going to use dimethyl formamide. Now here itself, I will tell you, you can potentiate the solvent power of a class 3 organic solvent to act as class 2 organic solvent, so that you can minimize the harmfulness due to this organic solvent. For example, you see now, I have done this. Ethanol I have used to dissolve this niacinamide. Niacinamide 15% solution was made by me, 15% niacinamide solution in ethanol. And in this ethanolic solution of niacinamide, the solubility of furosemide was about 5%. 5%, means soluble category. So what I have done, in place of dimethyl formamide, class 2, I have used 40 ml of 15% niacinamide in ethanolic solution. And then I have dissolved the drug, bromothymol blue indicator, NaOH titration, blank determination, and all they were done. And same results are there. So actually what I have done, I have potentiated the solvent power of a class 3 organic solvent ethanol to act as class 2 organic solvent like dimethyl formamide. So what is the advantage by doing so? By doing so, this is the advantage. If you are using ethanolic solution of niacinamide to dissolve the drug and you are performing titration, ethanol vapors will come in your body. But when you are using dimethyl formamide, those vapors will go. So it is better to substitute dimethyl formamide ethanol in this way. So what you are doing, you are utilizing the solubilizing power of a solid niacinamide to potentiate the solvent power of class 3, so that you can utilize class 3 organic solvent, which is safer than class 2 organic solvent like this. If you have any question, please note down in your copy, and at the end of the lecture we will have question answer session. Now, still better method. Now I am discussing hydrotrophic method, green method, without organic solvent. Assay of furosemide API hydrotrophic analysis. Weigh accurately about 0.5 gram furosemide API. Dissolve in 40 ml of 30% weight by volume sodium benzoate solution, aqua solution. You will get clear solution. Add few drops of bromothymol blue indicator, and titration is performed with 0.1 molar NaOH solution. Okay, so suppose the reading at this end point is say x2 ml. So then you will run a blank determination using another neat and clean conical flask, and then you will take 40 ml of Wait a minute, just please. For blink determinants, you will take 40 ml of 30% sodium benzoate solution in another conical flask. You will add few drops of room thermal value indicator. Then you will run 0.1 molar NaOH solution. Suppose the endpoint comes using Y2 ml of NaOH solution. So this Y2 ml of NaOH solution has been consumed by your sodium benzoate solution. So same has been consumed here also. So X2 minus Y2, this much volume of NaOH has been consumed by your drug. Using the same factor of pharmacopoeia, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide you can find on the drug content. Now you see what is the beauty of this method. Beauty of this method that you are not using any organic solvent. What you are going to use? You are going to use the solubilizing power of a solid, means sodium benzoate, means hydrotrophic solution of sodium benzoate. Sodium benzoate does not evaporate out. No vapors of sodium benzoate. Okay. Then it is economic also. Sodium benzoate solution 30%, about 1 liter cost about rupees 40. For rupees 40 per liter, 30% sodium benzoate solution in water, very cheap. And if you see the cost of say dimethyl formide or other solvents like ethanol, dimethyl formide, etc., this chloroform, etc., there may be 200 rupees per liter, 250 rupees per liter, and so on and so forth. So our main objective is not reduction in cost, but main objective is that you are preventing the human being against the exposure of human being from the vapors of dimethyl formide and so on and so forth. So in this way, this method is greener method because you have eliminated the use of any organic solvent. So method is you may say safe and economic both. Now now these few examples I will give very rapidly because in the same way, just like furosemide, essay of flurbiprofen API latest IPBP method, in this ethanol is involved for its dissolution for titrymatic analysis. Now ethanol has been replaced by sodium in the same method, same way, blink determination and all that. So what you have done, class 3 ethanol has been replaced by sodium benzoate solution, no organic solvent you are using. Naproxen, in this case, in IPBP method, the methanol has been used for its dissolution in pharmacopoeia method. This methanol is a class 2 organic solvent. I have replaced this methanol by sodium benzoate solution in the same way. Now, one more thing I would like to mention here, that the two methods, this one, naproxen method and flurbiprofen, dimethyl formide, both these drugs have been analyzed in IPC Ghaziabad lab, IPC, Indian Pharmacopoeia Commission Ghaziabad, from where we get our IP. In my present, they have seen the both methods, pharmacopoeia method as well as this hydrotrophic method. The same results were there, and I'm trying for their inclusion of these methods in pharmacopoeia. Of course, definitely a time will come when these methods will be incorporated in pharmacopoeia as well. Salicylic acid requires ethanol for its dissolution in IPBP method. This ethanol has been replaced by another hydrotrophic agent, sodium citrate. 30% sodium citrate solution is also very good solubilizer for solubilizing solvent, you may say, for the salicylic acid. So without ethanol, just by use of sodium citrate, you can determine the titrymatic, you can use this titrymatic analysis of this salicylic acid. Of course, the cost of sodium citrate is also nearly rupees 40 per liter and so on and so forth. It is also non-volatile. Ketoprofen requires ethanol for its dissolution for titrymatic analysis. Now, this ethanol has been replaced by sodium benzoate solution in the same way. Ibuprofen requires ethanol for its dissolution in pharmacopoeia method. It has been replaced by sodium benzoate solution the same way. Means without organic solvent, you are performing the titrymatic analysis. Means ultimately what you are doing, you are using hydrotrophic solutions as solvent system, which are replacing organic solvents. Now, another, briefly, I will discuss this method also. Assay of ibuprofen tablet, IP 2022. Weigh in powder 20 tablets. This is a pharmacopoeia method. Weigh accurately the powder equivalent to 0.5 gram of ibuprofen. dissolve the residue in 100 ml of ethanol, means class 3 organic solvent, and then titration is performed with any solution using phenolphthalein as indicator. Carry out the blink determination. Blink determination is done using 100 ml of ethanol in the same way. Okay, so here what is there? The involvement of chloroform, which is a class 2 organic solvent, and involvement of ethanol, which is a class 3 organic solvent, they have been replaced by hydrotropic method. Now, in this hydrotropic analytical method, what we are going to do, weigh the tablet powder equivalent to 0.5 gram ibuprofen, shake briskly for 10 minutes with 100 ml of 30% sodium benzoate solution. During this 10 minutes shaking, what happens? This sodium benzoate solution, hydrotropic solution, dissolves the ibuprofen present in the tablet powder. Then titration is performed with 0.1 molar NaOH solution using phenolphthalein solution as indicator. Blink determination is performed, and then you find out the drug content using this factor 1 ml of 0.1 NaOH is equivalent to this much of ibuprofen, like this. So here in this hydrotropic method, what you are using, sodium benzoate solution alone. Okay, in previous method and pharmacopeial method, chloroform class 2 and ethanol class 3. So both organic solvent have been replaced by sodium benzoate solution. Now these are other drugs which can be, for which you can carry out the titematic analysis using hydrotropy or mixed hydrotropy. Now coming to UV now after titematic analysis, UV spectrophotometric and estimations of pharmaceutical dosage forms are poorly water soluble drugs using hydrotropic solutions without organic solvents. Now the example is that of tindazole tablet. Tindazole is a poorly water soluble drug, so water cannot be employed for its UV spectrophotometric analysis. So this is the method of IPBP. Weigh tablet powder equivalent to 0.15 gram of tindazole. You have to add 20 ml of methanol in a 100 ml volumetric flask, and then shaking is done for sufficient time. During this shaking, this 20 ml methanol dissolves the tindazole present in the tablet powder. Then volume is made up to the mark, up to means 100 ml with methanol. Then you have to filter out the water, you may say the insoluble excipients. Then from the filtrate, you will take 10 ml and dilute it up to 100 ml with methanol. Further, you will take 10 ml of this solution and dilute it up to 100 ml with methanol. So total is methanolic method. Then this solution, the absorbance of this solution is noted at 310 nm, 310 nm against methanol. In methanol, the peak of tindazole comes at 310 nm. So you have to measure its absorbance at 310 nm. Then calculate the content of tindazole taking 356 as the specific absorbance at 310 nm. Okay, means this is the E1% 1 centimeter value. So using this, you can find out the drug content of your tablets. So what is there in this pharmacopeial method? It is utilizing methanol, which is a class 2 organic solvent. Now it has the methanol has been replaced by sodium benzoate solution. Now in hydrotropic method or eco-friendly method, weigh tablet powder equivalent to 50 milligram of tindazole, add 20 ml of 30% aqueous sodium benzoate solution and shake for 10 minutes briskly in a 20 ml volumetric flask. So what you are doing, you are weighing such an amount of tablet powder which contains 50 milligram of tindazole. You are transferring it in a 25 ml volumetric flask. Now you are transferring 20 ml of 30% sodium benzoate solution. Then shaking is done for 10 minutes briskly. During this shaking, sodium benzoate solution dissolves the tindazole present in the tablet powder. Then volume is made up to the mark, means 25 ml with water. Then filtration is done to remove insoluble excipients. And then you take 1 ml of the filtrate and dilute it up to 100 ml with water, distilled water. Now the absorbance of this solution will be noted. Measure the absorbance at 318 nm against reagent blend. 318 nm, why? Because in aqueous system or in water, the peak of tindazole comes at 318 nm. In methanol, 310 nm. Due to change in solvent, that there is shifting of peak. So in aqueous solution, you will see the peak at 318 nm. So you have measured the absorbance of the solution at 318 nm against reagent blank. How this reagent blank is made, so from the point of view of students, let me explain you. Reagent blank, how will you make this reagent blank containing sodium benzoate? So you will take 25 ml of volumetric flask, 25 ml volumetric flask, transfer 20 ml of sodium benzoate solution 30%, make up the volume to the mark with water. Now from this 1 ml you will take and dilute it up to 100 ml with water. So this is the reagent blank solution for this analysis. This reagent blank solution contains the same percent of sodium benzoate which is present in your sample solution. So when you keep them in sample solution is kept in sample cuvette, reference this reagent blank is kept in reference cuvette. Both cuvettes contain same percentages of sodium benzoate. There is neutralization of effect of each other, or you say the sodium benzoate. So whatever the peak comes, it is due to your drug only. So in this way, you have noted its absorbance at 318 nm. Okay. Now, what was the strength of drug in this particular sample solution? So you may see the procedure again. What you have done, 50 milligram drug. Firstly, it has gone 20 ml of sodium benzoate solution, shaking, then dilution is with water. One more thing to be kept in mind is that you are not diluting it again with sodium benzoate solution. No, you are diluting with water. Okay, so you take only 20 ml of sodium benzoate solution, remaining is always water. Okay, so what I was saying here, what you have done, 50 milligram drug has gone in 25 ml of the solution. 50 milligram, 25 ml. 2 milligram per ml. 2 milligram per ml means 2000 microgram per ml solution is there. Now from this you have taken 1 ml and diluted it up to 100 ml, 100 times dilution. So from 2000 microgram per ml you have come up to 20 microgram per ml. Okay, so this solution contains nearly 20 microgram per ml strength of your joule. Okay, now you have to find out the drug content of your tablet. So for that, you require a calibration curve. How this calibration curve will be obtained? You will make 5, 10, 15, 20, 25 mg per ml solutions, standard solutions of drug. And same will be, 5 will be the reagent blanks. 5 mg per ml drug, 5 mg per ml is related to that reagent blank, 10, 15, 20 like this. So 5 respect to reagent blank will be made, and then the absorbances of these solutions will be noted at 318 nm, and using these absorbances you can plot a calibration curve. You will get a regression equation that will be utilized to find out the drug content of your tablets. What is the beauty of this method? The beauty of this method is that you are not using methanol. Pharmacopoeia utilizes methanol, you are using sodium benzoate. Sodium benzoate is cheaper. I have told you the rupees 40 per liter solution, 30% sodium benzoate. Number one, cheaper. Number two, sodium benzoate does not interfere above 292 nm. Means, in other words, you may say the cutoff point for sodium benzoate is 292 nm. So always, whenever you want to use sodium benzoate, always the peak of your drug should be above 292 nm. For example, in this case, it is 318 nm. Nalidixic acid 330 nm, metronidazole, benzoate on metronidazole 320 nm, naproxen 333 nm, and so on and so forth. So like this. So sodium benzoate is a good hydrotrophic agent and can be used only for those drugs which show at least one peak above 292 nm. Okay, like this. So anyway, sodium benzoate does not interfere in UV analysis. So in this way, you are seeing the green method. Without the use of any organic solvent, just by using the hydrotrophic solutions, you are going to perform the UV spectrophotometric analysis. Now, few more examples you may see. These have been done. Naproxen tablets, methanol is used in IP method. Sodium benzoate has replaced this methanol in the same way. Naproxen is estimated at 333 nm. Indomethacin capsule, IPBP method, methanol, In our method, sodium benzoate at 320 nm it is estimated. Diazepam capsule, diazepam is estimated at 354 nm using, and methanol has been replaced by mixed hydrotropy. Okay, at 354 nm, you have replaced methanol. Now, suppose, now in case of say atenolol tablets, IPPP method involves the use of methanol, again, methanol. Now, this methanol of pharmacopel method has been replaced by urea solution. Now, in this case, you cannot utilize sodium benzoate because the peak of atenolol comes at 275 nm. At 275 nm, sodium benzoate solution will interfere on your UV analysis. So, sodium benzoate is not utilized. Now, you will utilize urea solution. Urea cutoff point is 240 nm. And here estimation will be performed at 275 nm. So there is no interference of urea. And in this way, urea solution has replaced methanol. Okay, so again, this is hydrotrophic method. Now, one more important information I would like to give you, that this work, analytical work using hydrotropy, I have started from the year 2004-05 when I was doing my PhD. From that time, so many papers I have published, and then from so many colleges of India and of course abroad, so much work has been done in the field of titematic and UV analysis, and so many papers have been published, and then a chapter has been written in an international publisher book, that is Springer publication book. That is the book by name of Green Chemistry book. It is a green chemistry book, and in there 13 chapters are there. Out of those 13 chapters, chapter number 6 is that of hydrotrophic analytical techniques. Okay, and who has written this chapter in this green chemistry book? There are 4 authors, associate professors, they are the academicians. One from Egypt, 2 from Saudi Arab, 1 from Japan. So 4 such academicians, they have written that chapter, and now you may say it has been internationally recognized. So this concept has gone from India to, you may say, the world, or it has been now internationally recognized, and now more and more work will be done in this way. Anyway, now coming to other utilization of this hydrotrophic method in TLC, thin layer chromatography, green chemistry. Now this is a published paper reference. Okay, now here you will say employment of hydrotrophic and mixed hydrotrophic solutions as mobile phase to carry out TLC, precluding the use of organic solvent. This is a published paper. It is available online. What has been done in this paper? 3 M.Pharm students were involved in this work, and of course this work has been applied for Indian patent also. Applied for Indian patent. What does it contain? In this particular, say, TLC project, 9 water-soluble drugs were selected. 9. Up to this losartan potassium, and you see previous these one, propanol, hydrochloride, guaifenesin, etc. 9 water-soluble drugs were selected by the M.Pharm student team, and the solutions, 2% aqueous solutions were made for each and every this drug, and these solutions, 2% distinct solutions were used to put the spot on the silica gel plate, and after putting the spot, these plates were heated at about 60-70 degrees centigrade to remove water, and then these plates were developed using different blends. Now you see the blends. Blend 1, for each drug, 8 blends were used to develop the plate. Say, for example, blend 1, 5% sodium benzoate, 5% sodium acetate. This solution was used. When the plate was developed, after development of the plates were exposed to 60-70 degrees centigrade in oven for the removal of water. And when they were dried, plates were dried, then for identification of spots, iodine chamber was used to find out the spot. Okay, so in this way, means what you are saying, that only the aqueous solution of sodium benzoate and sodium acetate without any organic solvent you are going to perform the thin layer chromatography. Otherwise, up to this time, whatever the TLC, you will find always 1 or 2 or 3 organic solvent, they are always utilized. Okay, just you can see here also, these are the pharmacopil method of IP. Here you see, for example, in case of ciprofloxacin hydrochloride IP method, there is involvement of dichloromethane, methanol, acetonitrile. In case of guaifenesin, carbon tetrachloride, ethanol, etc. रुक नहीं पा रहा. Wait a minute, थोड़ा स्टूडेंट्स को शांत कराओ. So, as in case of guaifenesin IP BP method, you are seeing the carbon tetrachloride, which is class 1 organic solvent, very harmful, and ethanol, class A organic. So, always in TLCs, you will find the organic solvent. Now, you see, I told the students to use 8 blends to develop the plate, and then I told them that you select such blends which give spots without tailing effect. So in case of, you see this propanol hydrochloride, 8th blend, 7.5% niacinamide and 7.5% sodium benzoate was selected because there was no tailing in this and the RF value was 0.8. In case of guaifenesin, blend 1, 2, 3, 4 and 7 were selected without tailing effect. Okay, like this. So what new thing you are seeing in this particular project, that without any organic solvent, we are performing the thin layer chromatography. Okay, now so what you can do in all the colleges, there are always certain students who want to do carry out some research work. So such research work can be done by even B Pharm second year, third year, final year students. Very cheap method, and in 4 or 5 days you can perform a new project. And what is the object of this project? That you can show you may say the world researchers that without the use of organic solvent also you can perform the thin layer chromatography and so on and so forth. Now you listen one sentence from me very carefully. For each and every compound, I'm using the word for each and every compound, the TLC can be performed using hydrotropic solution, mixed hydrotropic solution or mixed solvency concept without the use of any organic solvent. Now here, if your compound selected is water soluble, so smaller concentrations of hydrotrophic agents are sufficient to develop the plate. But if your drug is poorly water soluble drug, then definitely higher concentrations, say 20%, 25 or 30% concentrations of hydrotrophic agents can be shall be employed for to perform the TLC and so on and so forth. Okay. If you have any question, please note down. At the end of the lecture, we will have question answer session. Now, after TLC, now HPLC or HPTLC. HPLC or reverse phase HPLC. So now here you see this is the reference of a published paper, novel RP, reverse phase HPLC method development and validation of cefixime in bulk and its doses form by using hydrotrophic solution as mobile phase. Here this work has been done by Remy SL madam. She is assistant professor in Kerala University. She has done PhD in UV analysis using hydrotropy, HPLC analysis using hydrotropy. So this is her research work. So she has utilized cefixime tablets to carry out this reverse phase analysis, and what she has employed mobile phase, 6% weight by volume aqueous solution of sodium acetate, adjusting the pH to 6.2 with acetic acid. So this solution was used as mobile phase to carry out the reverse phase HPLC of this drug. This means only aqueous solution of sodium acetate was sufficient to carry out the TLC, this HPLC. Otherwise, in normal HPLC, always either methanol or acetonitrile or their combination or other organic solvents are always involved. Now, one thing I would like to let me finish one more example, then I will tell you. Now, this is another published paper of Remy SL madam. a novel, eco-friendly, cost-effective mobile phase for HPLC, simultaneous estimation and validation of paracetamol and diclofenac sodium in bulk and pharmaceutical formulation by reverse phase HPLC using hydrotrophic solution as mobile phase. Now here in this particular, this Remy madam has done a lot of validation parameters. So these both papers, they are available online. Now in this, the mobile phase used by Remy madam was 5% urea solution. 5% eco solution of urea without any organic solvent was employed as mobile phase to carry out the reverse phase analysis of such tablets which contain two drugs, paracetamol and diclofenac sodium simultaneously. Okay, now you listen to me, my one sentence again for HPLC. For each and every water-soluble compound, reverse phase HPLC is possible using hydrotrophic solutions or mixed hydrotrophic solutions or mixed solvent systems. But I am not incorporated the words insoluble drug. You leave in water-insoluble drugs, there are limitations for insoluble type of drugs for reverse phase HPLC because high concentrations of hydrotrophic agent cannot be used in HPLC, otherwise they will block the columns. So what I am using the words, only you select water-soluble compounds and you can perform the reverse phase HPLC of that compound without the use of any organic solvent. Okay, if any one of you, whether you are a student or teacher or researcher, if you want to do such type of work, you can contact me. At the end of the lecture, I will give my contact number, mobile number, WhatsApp number. So you can be associated with me and you can carry out such work. Now after this, coming to mixed hydrotrophy, I have told you that hydrotrophic solubilization is more than 100 years old concept. So many persons, they have developed the injections using hydrotrophic solutions, concentrated solution, 30% sodium benzoate and so on and so forth. But such high concentrations of hydrotrophic agents cannot be employed, say for example, to make the aqueous intramuscular injection because of the toxicity of the large concentration of hydrotrophic agents. So, of course, in 100 years, so many research work papers have been published, but marketable formulations could not be made. Why? The reason is large concentration of hydrotrophic agent cannot be utilized to make the intramuscular injection. So from the year 2008, I have started very new concept of mixed hydrotrophic solubilization, so that you can make the marketable formulation. So first, let me explain you this with example. Now you see this table. I am explaining mixed hydrotrophic solubilization. This is the table which gives inactive ingredient guide, means the concentrations of various additives which are employed to make aqueous intramuscular injection. It is given in a book, a thick book, Inactive Ingredient Guidebook 2019. What does this book give? Inactive Ingredient Guidebook. This gives the concentrations of various additives which are employed in various formulations, pharmaceutical formulation. So from that book, I have selected such 19 additives which are employed to make aqueous intramuscular injection. Out of these 19, you see number 17, 18 and 19. They can be used in 5% concentration. You cannot employ 6% like. And in previous means up to this 16, you can employ in 10% concentration without having giving the toxicity. Okay, so for example, you see this number 13, sodium benzoate 10%. In 2019 book, it does not give in intramuscular injection more than 10% sodium benzoate concentration. Means if you are using 10% sodium benzoate, it is not toxic in intramuscular injection. So you can use 10% sodium benzoate in your aqueous intramuscular injection. Now we see number 8, sodium acetate, 10% is not toxic, means it can be used in aqueous intramuscular injection. Then you see number 2, sodium citrate 10%, you can use. Now if you combine these 3 hydrotrophic agents, sodium benzoate 10%, sodium acetate 10%, sodium citrate 10%, 30% solution is there, and in this 30% solution, when solubility of drug is enhanced sufficiently to the desired level, you can make its aqueous intramuscular injection. because this mixed hydrotrophic solution contains safe concentrations of these hydrotrophic agents. So in this way, mixed hydrotrophic solutions can be employed to make marketable formulation, because these concentrations are allowed in inactive ingredient guide 2019. Okay, so this is mixed hydrotrophic solubilization, and I have started this mixed hydrotrophic solubilization first time in the world, you may say, in the year 2008. Okay, and so many papers have been published from my side, and seeing these papers, one scientist, Dr. Hossein Misri of Egypt, he has also employed mixed hydrotrophic solubilization to make marketable formulation. So anyway, what I want to say you, although 100 years have gone, no one has used a marketable formulation. No one could make like this. So anyway, but mixed hydrotrophic solubilization can solve the problem of this toxicity issue, and you can make marketable formulation. So not only ecocenter muscular injection, so many formulations you can make, but you will have to see the inactive ingredient guide to select the maximum concentrations of hydrotrophic agent which can be employed safely. Now coming to the work which has been done here in my SGSITS college by Hitesh Jagwani, 2008 M.Pharm student, and what he has selected furosemide, poorly water soluble drug. The solubility of furosemide was checked in water at room temperature. It was found to be 0.008% by Hitesh Jagwani. Then 4 hydrotrophic solutions were applied, 40% urea, sodium acetate, sodium benzoate, sodium citrate. You are seeing the solubilities obtained in those, they are before you. Then I told the student to make 15-20 blends, mixed hydrotrophic blends, keeping the 40% strength constant, varying different, taking varying concentrations of these 4 hydrotrophic agents. Okay, then from that list, so sometimes there were ready to solubilizing effect, sometimes there were synergistic. Out of that list of Hitesh Jagwani, 3 examples I have brought for you. That is number 6, 15% sodium benzoate, 5% sodium acetate, 5% sodium citrate, 15% urea, total 40%. The solubility achieved was 4.247%. Otherwise, maximum solubility in single hydrotrophic solutions was in sodium benzoate, as you are seeing in the number 4, 2.1%. So here it is nearly double. When 1 + 1 is equal to 2, it shows its additive effect. If 1 + 1 acts as 3, 4, 5, this means synergistic effect. When the obtained response is more than the sum of the additive response, then we call it to be synergism. So here in case of this number 6, you are getting synergistic solubilization. So by mixing the hydrotrophic agents, you can have additive effect. Additive effect is also good. A synergistic effect is better because for the same solubility enhancement, you will require a smaller concentration of hydrotrophic. So in this way, mixed hydrotrophic can be utilized to make the marketable formulation. After that, 2008, I have started in 2019, this another concept, first time in the world, that is a mixed solvency concept. I've explained I told you that there are 2 parameters in mixed solvency concept. Number 1 parameter says each and everything present in this universe has got solubilizing power, whether the thing is gas, liquid or solid. Number 2 parameter says that since you know that each and everything has got solubilizing power, this means whatever the additives are used in making the pharmaceutical formulation, they must also possess solubilizing power. So what you can do in case of formulation, if you want to use in formulation the solubility enhancement, you can make strong solutions using smaller concentrations of several additives, because additives may also demonstrate the solubilizing power for your drug. So using these concentrated solutions in the safe concentrations and without toxicity, you can employ in making pharmaceutical formulations. One example, you see this one, it is before you. This I have made one mixed solvent system, of which the pH was 7 neutral. 4 solid solubilizers were utilized: sodium benzoate 5%, sodium caprylate 5%, sodium citrate 5%, and fluoxan 4 total became 20%. So this 20% strength solution in water the pH was 7, and now all these 4 solids were in solution form. These molecules of all these four solids were in liquid state. As I have told you, they will take part in hydrogen bonding and weak butterworth forces. Anyway, now I have checked the solubility of several poorly water soluble drugs in water as well as in the solvent system, and I have found several times solubility enhancement in those cases. So 2 examples I have brought for you. Number 1, furosemide. The solubility of furosemide in water at room temperature is less than 1 milligram per ml, but in this particular blend, the solubility is about 35 milligram per ml. So 35 divided by 1 means about 35-fold solubility enhancement is there. Okay, what is the reason for solubility enhancement? The same reason. These all 4 solids, their molecules are in liquid state and they take part in hydrogen bonding and weak butterworth forces. The molecules of furosemide, that's why its solubility is enhanced. Anyway, now what is the advantage of mixed solvency concept, this blend which you have made? It is this, that now if you see, suppose in market, the furosemide tablets, they are running in 20 milligram and 40 milligram strength. 20 milligram tablets are available, 40 milligram tablets are available. Suppose you want to make 20 milligram per ml injection, I am talking about. This means, you see, in water solubility is less than 1 milligram per ml. You cannot make 1, 2, 3, 5 ml means solution. You will get suspension. You can make suspension. But now, since 20 milligram can naturally be dissolved by 1 ml of this blend, so you can make its intramuscular injection. Similarly, you see this pyroxychem, solubility is 20 milligram per ml in this blend. In water, poor solubility 1 milligram per ml. So 20 milligram per ml injection can be developed. The pyroxychem tablet of market, they are 20 milligram tablets. So you can make 20 milligram per ml injection. Okay, so in this way, you are seeing the solubilizing effect of these solids. It is increasing the solubility of your insoluble drug. Now, one more very good advantage of this mixed solubility concept is this, that you can make dry powder injection for reconstitution. Suppose your insoluble drug is you will say, what we call hydrolyzable. Suppose your insoluble drug is hydrolyzable. Means you cannot make its aqueous injection. Means for more than 1 month or so, you cannot have, you cannot make ready-made injection having sufficient self-stability or you say stability or expiry period. So what you can do, you can utilize the solubilizing power of solids, additives of course, to make dry powder injection for reconstitution. For example, you see, suppose you want to make dry powder injection of furosemide, 20 milligram per ml. So now you see, how will you make? Of course, I am not saying that furosemide is a hydrolyzable. I am not saying this. But what I want to say, just I am giving one example. Suppose it is a water soluble, water hydrolyzable drug, for example. So 20 milligram per ml, you want to make dry powder injection for reconstitution. So for 1 ml solution, you will require how much amount of sodium benzoate, caprolate, etc. 5% you have utilized in this particular blend. 100 ml contains 5 gram. 10 ml will contain 500 milligram. 1 ml will contain 50 milligram. So 50 milligram sodium benzoate, 50 milligram sodium caprolate, 50 milligram sodium citrate, 50 milligram polar summer 407 in a vial, together with 20 milligram furosemide, all are in solid state, and they are in vial. At the time of need, you will add 1 ml water, you will reconstitute, you will get a clear solution because of solubilizing power of these solids. So in this, now the shelf life of such type of dry powder injection can be 1 year, 1.5 years, 2 years, and so on and so forth, because in solid state it is not hydrolyzable. So like this, anyway, there are so many applications. Now I am going to describe some briefly the application part of applications of mixed solvency concept and formulations. Now see, dry powder injection for reconstitution of poorly water soluble drug can be certain selected for 1 ml injection. Of course, as you are seeing this reference, it is available online. PDF you can get from internet. You can find this published paper. What has been done here? The M.Pharm student has used this. Then one more thing, let me tell you. Those students or teachers, researchers are interested for such work. I can send the soft copies of these theses and pharmacists to you. Also, I have sent it to several researchers. For what? So that you can see step by step that how to proceed for a particular project, MPhar project or PhD project or like that. So anyway, in this particular MPhar project, a student has used insoluble drug candesartan Selexatel. 8 milligram tablets are in market. So we are going to make it 8 milligram per ml injection. Sodium caprolate 10%, sodium benzoate 5%, sodium acetate 5%. They give good solubility. They are giving good solubilizing power for your drug. So for making 1 ml injection in vial, you will put 50 milligram acetate, benzoate 50 milligram and 100 milligram sodium caprolate together with 8 milligram candesartan Selexatel, and at the time of need 1 ml water, reconstitute you will get clear solution due to solubilizing power of these solids. So in this way, you can make dry powder injection for reconstitution. Solid dispersions can be developed for faster resolution. And of course, this published paper reference is given at the bottom. PDF is available online. In this particular MPhar project, a student has used torsemide. 2.5 gram of torsemide, which is water-soluble drug, has been dissolved with the help of solubilizing power of 1.25 gram sodium citrate, 1.25 gram sodium acetate, 2.5 gram beta-cyclodextrin, and 5 gram sodium caprolate, and minimum water. They were dissolved. Then drug was dissolved. Clear solution was obtained. Water was removed during heating. Shaking was done with magnetic stirrer. Water was evaporated out. When semi-solid mass was obtained, that was kept in lumps in the China days or watch glass. It was exposed to about 60-70 degrees centigrade in oven for the removal of water. After drying, it was powdered and sifted through fine sieve. So it is the solid dispersion of this poorly water-soluble drug to make fast tablets for fast dissolution source. Such things can be done. Which, of course, what you are doing here, you are utilizing the solubilizing power of safe additives, solid additives. Another application in liquid solid system of poorly water soluble drugs. Here, like, as you know that in liquid solid system, at least one non-aqueous solvent is selected to make such a liquid solid system, like glycerin, propylene glycol, etc. Okay, then you see, now you see just this published paper, the reference is at the bottom. What this MPhar project has been done using, you may say this is for pyroxychem water soluble drug. The solubility of pyroxychem in propylene glycol, which is a non-aqueous solvent, which was used in the liquid solid system. The solubility of pyroxychem was very poor, means less than 5 milligram per ml. Now you see 5 milligram per ml. So the tablets of pyroxychem 20 milligram tablets are being marketed they are being marketed. For making it's a solution, you will require at least 4 ml of propylene glycol, 4 ml for 20 milligram, 5 milligram per ml. So 4 ml means nearly 4 gram liquid, then adsorbent 12 gram, 16 gram. You cannot make it a tablet or capsule, no. Then what should you do? You should use mixed solvency concept to improve the drug loading in your this solvent system, so that in the minimum or a small quantity of solution, your desired amount of drug can be dissolved. For example, in this particular MPhar project, what has been done? The solubility of pyroxychem in propylene glycol was enhanced in presence of sodium caprolate and sodium acetate 10%. So total 20% strength. In this solution, the solubility of pyroxychem was found to be 120 milligram per ml. 120 milligram per ml. In propylene glycol, 5 milligram per ml. 120 divided by 5, 24-fold enhancement in solubility was there. Now you assume this 120 milligram per ml is 100 milligram per ml. Your blend, you are having in 1 ml, 100 milligram drug in solution form. For 20 milligram, you will require 0.2 ml of this solution. 0.2 ml means nearly 200 milligram. So this 200 milligram liquid system, solution system can be absorbed by about 600, 800 milligram of adsorbent. So less than 1 gram of, you may say, the free-flowing powder is sufficient to make tablet or capsule. So what you have done? You have improved the drug loading in your non-aqueous solvent system using the solubilizing power of solids. That's why a small volume is sufficient to dissolve the desired amount of drugs. In this way, liquid solid system they were developed, and of course, it is a new concept. And those who are interested, they can ask me. I can send you the soft copy of thesis so that you can also perform such projects. Aqueous injection of poorly water soluble drug using mixed solvency concept. Published paper reference is there. Formulation development of dry powder injection for reconstitution of poorly water soluble drug indomethacin. This is another work on dry powder for injection. So indomethacin insoluble drug was selected in this particular published paper. It is also available online. Then coming to other example here, vaginal film was developed. Of course, by improving the drug loading, the size of film was reduced using the solubilizing power of solubilizers or additives, you may say. Improvement of drug loading in ACDDS using mixed solvency concept. MFAR project is there. Improvement of drug loading in oral film using mixed solvency concept. This is another work. Just reduction in film size using solubilizing power of solubilizers, additives. Mixed solvency concept, this novel application of mixed solvency concept in formulation and development of fast dissolving oral film, a poorly water soluble drug, amlodipine mesylate, and their evaluations. Published paper references before you. In all the formulation, drug loading was improved using the solubilizing power of additives. Now, some interesting, another interesting part of this, you may say, this lecture, that solids can also be employed for the extraction. Now, I'm going to discuss extraction, which is useful for pharmacognosy students or phytochemistry students or teachers. So extraction of active constituent using solvent action of solids. Reference of published paper is eco-friendly extraction using solids in novel application of mixed solvency concept. And this is a published paper reference available online on PDF. PDF is available online on Google search. And of course, the same work has been applied for Indian patent also. What has been done here? Briefly, I would like to discuss this. And of course, if you have any doubt, please note down your question at the end of the lecture. I will answer them. Now here, just briefly, because so much time has gone. So briefly, I would like to tell you how the solids can be employed for extraction. Means we have to employ the solubilizing power of solids after, say, for example, melting after dissolution in solvent, in different you will say the conditions. For example, number one, you see melted thymol. Melting point of thymol is 48 degrees centigrade, about 50 degrees you may assume. In a test tube, 1 gram thymol was kept. Thymol, 1 gram. Melting point 48. This test tube was immersed in water bath. At about 50 degrees centigrade, you will have clear colorless melted thymol liquid, which can be shaken like any liquid. Then the solubility of sesame oil. Sesame oil was used in this particular study as active constituent, which is found in sesame seed powder. So 1 gram melted thymol at 50 degrees centigrade, 0.1 ml sesame oil dissolved, 0.1 ml, 0.1 ml. More than 1 ml sesame oil was nicely dissolved by 1 gram melted thymol. Means very good solubility of melted thymol for sesame oil. Now I will tell you how extraction was done. 3 grams sesame seed powder in a test tube. 3 grams sesame seed powder, which contains sesame oil. 9 gram, 3 times more, 9 gram thymol in test tube, water bath, melted at about 50 degrees centigrade in melted condition of thymol, 30 minutes shaking. During this 30 minutes shaking, melted thymol dissolved the sesame oil which was present in sesame seed powder. Then through cloth, it was strained, and strained liquid containing melted thymol containing dissolved sesame oil was exposed at about 60 to 70 degrees centigrade in China days in oven for the removal of thymol in nearly 1 hour at about 70 degrees centigrade. Thymol was removed. Remaining was sesame oil, which is fragile, non-volatile. Of course, some traces of thymol were there, but you have obtained sesame oil. What you have done here in this case, you have utilized melted solid as solvent for Okay, so in this way, I'm not saying that you use thymol, menthol, etc., but it gives an idea for a researcher that solids can also be employed for the extraction of active constituent from herbal powders. Another example, number 2, you see melted menthol. In the same way, melted menthol extracted out sesame oil, then at room temperature now in solution. Number 3, 50% bidwiodum thymol in ethanol. This is solution of thymol in ethanol at room temperature. The solubility of sesame oil was very nice. 1.4 ml sesame oil was nicely dissolved by 1 ml of the solution, means very good solubility. Now extraction, how extraction was done using this solution? 3 gram sesame seed powder in a test tube, 9 ml of this solution, 50% thymol and ethanol, 30 minutes shaking at room temperature. This solution has dissolved sesame oil which was present in the sesame seed powder. Filtration, filtrate. What does this filtrate contains? Ethanol, thymol and sesame oil. And then this liquid was kept in oven at 70 degrees centigrade. When 1 hour ethanol was evaporated out, thymol was evaporated out, remaining was your sesame oil. Of course, the study is not so much refined, this public paper is not refined, but it gives some idea to the researcher that solids can also be employed for their solubilizing power, for the extraction of active constituent. For example, let me explain to you that suppose you have got an active constituent which is, you may say, has got poor solubility in ethanol, and you cannot extract that constituent using ethanol as solvent. And suppose because of good solubility you are going to use chloroform or carbon tetrachloride, benzene, etc. What you can do? You can potentiate the solvent power of this ethanol using such solids, and then you can utilize in your extractions. For example, you see in this particular sesame oil extraction, the manufacturers of sesame oil in the end of the industries, what do they use? They use either hexane as solvent system to extract out sesame oil from sesame seed powder. Hexane is class 2 organic solvent. Traces of hexane in sesame oil are harmful for human being. Now you see why they have not used, means manufacturers, why they have not employed ethanol. The reason is ethanol is poor solvent for sesame oil. Sometimes the manufacturers of oil, they use combination of ethanol plus hexane. Now they extract out sesame oil and then ethanol and hexane, they are removed. But then also there are traces of ethanol as well as hexane. Now in this particular case, what I have done, this is now another example. I told you that you can potentiate the solvent power of a class 3 organic solvent to act as class 2 or class 1. For example, here you see hexane, class 2 organic solvent. Ethanol, class 3 organic solvent, poor solvent for sesame oil. But when you dissolve thymol in ethanol, now this solution has become a strong solution like hexane, and hexane can be replaced by this solvent system. So here in this case, ethanol containing thymol, it is being used for the extraction because this thymol improves the solubilizing power of ethanol so that this solvent system acts as hexane in solvent character, and it can be anyway. So in this way, class 3 organic solvent can be made a strong solvent like class 2 by using solubilizing power of solids. Now, coming towards end, now some more useful information. I have made 7 YouTube videos. Each video is of about 40 to 45 minutes duration. For example, number 1, if we put these words on Google search, eco-friendly lecture series number 1, you will get this video which gives eco-friendly and economic UV spectrophotometric analysis of poorly water-soluble drugs by application of hydrotropy, mixed hydrotropy and mixed solvency concept without the involvement of organic solvent. If we put words, eco-friendly lecture series number 2, YouTube video, eco-friendly and economic titrimetric analysis of poorly water-soluble drugs by application of hydrotropy, mixed hydrotropy and mixed solvency concept without the involvement of organic solvent. Number 3, gas, liquid or solid present in this universe has got solubilizing power, mixed solvency concept. Those who are interested to know more deeply this mixed solvency concept, they will see this one. Number 4 is for TLC of drugs. Those who are interested for TLC, they will see this one. Number 5, Reverse phase HPLC, those who are interested for this, they will see this. Number 6 is for dry powder injection for reconstitution. Such types of projects should be done in your college also. Eco-friendly lecture series number 7. Application of mixologist concept to make innumerable eutectic liquids. Eutectic liquids may act as solvent in vast field of science. This is an art. Those who are interested to get more and more eutectic liquids, they can see this YouTube video. Now coming towards end is thank you. And once again, I will thank you, Dr. Mithun Bhomik. Because of your efforts, I am here with you, and because of you, I am able to give this, to deliver this lecture for a large number of candidates. So I am again thankful to you. And this is my, here is my mobile number 94066219007, which is WhatsApp also. So those students or teachers or researchers are interested to have this PowerPoint presentation or soft copy of thesis or to discuss any other related matter, they can talk frankly to me. No problem, no need to hesitate. Now I am coming to you. ये कंट्रोल और F दबाते हैं ना इसको, ये ना, अच्छा अब इस पे स्टॉप कर दो, स्टॉप से करेंगे.
Thank you so much, sir, for your valuable presentation. I would now like to request any students or faculties, if you have any questions or queries, you may go forward and ask Maheshwari sir.
Very good afternoon, sir. Hello.
कोई question? पूछिए.
Sir, I am the faculty of BCPSR Pharmaceutical Chemistry Department. Sir, मेरा एक क्वेश्चन है सर कि जब हम सर माइक्रोवेव में कोई भी रिएक्शन करते हैं तो माइक्रोवेव रिएक्शन में कैसे हम सॉल्वेंट को सिलेक्ट करें, क्योंकि जब हम कन्वेंशनली जो रिएक्शन करते हैं उनमें
आपको वॉइस ब्रेक, सुनो वॉइस ब्रेक हो रही है, फिर भी मैं सुन रहा हूँ.
सर, एम आई ऑडिबल सर?
हाँ.
सर मेरा क्वेश्चन ये है कि सर जब हम माइक्रोवेव में अगर कोई भी रिएक्शन करते हैं तो वहाँ पे सॉल्वेंट सिलेक्शन हम किस बेसिस पे करें? जैसे कि सर कन्वेंशनली जो सॉल्वेंट सिलेक्शन होता है, कन्वेंशनली के जो मेथड होता है वो थोड़ा सा डिफरेंट है माइक्रोवेव में, क्योंकि माइक्रोवेव में थोड़ा सा पोलैरिटी का भी फैक्टर आता है. तो सर हम
सुनो, आपकी आवाज तो ब्रेक हो रही, लेकिन मैं समझ रहा हूँ आप जो पूछना चाह रहे हो. मैं आपको बताता हूँ कि आप, पहला हमारा जवाब है यस, आप कर सकते हो. तो कर सकते हो तो कैसे कर सकते हो? तो उसके लिए पहले हमें आपसे वो पता करना पड़ेगा कि जैसे आप क्या क्या ले रहे हो और क्या चाहते हो, वो मेरे को समझ में आ जाए तो मैं बता दूं. आप चाहो तो मेरा नंबर नोट कर लो, आप हमसे बाद में पूछ सकते हो. अभी आवाज आपकी मेरे ख्याल से किसी को भी समझ में शायद पूरी नहीं आ रही होगी, लेकिन हमारा आंसर यही है जो आप पूछना चाह रहे हैं कि यस वी कैन डू. लेकिन उसके लिए हमें थोड़ा करके देखना पड़ेगा और हो जाएगा, निश्चित रूप से हो जाएगा.
ओके सर, थैंक यू सर, थैंक यू.
आपका नंबर बताओगे?
यस सर,
नंबर बताओगे?
यस सर.
हाँ बोलो.
सर कैन यू प्लीज शेयर योर नंबर?
अब आपका एक्चुअली सुनो, वो भी नहीं पता चल पाएगा मोबाइल नंबर भी, रहने दो. आप तो हमें अलग से कांटेक्ट कर लेना, अलग से कांटेक्ट कर लेना.
ओके
है ना,
बता
दूंगा.
ओके सर.
एनी अदर क्वेश्चन? ओके.
Thank you, Dr. Maheshwari sir, for your. Does any student or faculty have any other question? You may go forward with your query. Okay. Thank you, Dr. Maheshwari sir, for your time and your valuable presentation. I would now like to hand over the podium to our respected principal, Dr. Mithun Bhomik sir, for his vote of thanks.
Thank you, Swagata. Dear Dr. Maheshwari Sir, on behalf of our entire team, I would like to extend our heartfelt gratitude for her incredible contribution to the webinar Your presence and expertise truly enrich the session, leaving every participant feeling enlightened and inspired. Your depth of knowledge and ability to communicate complex concepts in a clear and engaging manner captivated our audience. The insights you shared during the webinar were truly invaluable. Your research and experience in the field have not only enlightened us but also broadened our understanding of the topic. Your in depth analysis and practical examples have equipped us with actionable knowledge that we can apply in our professional life. Once again, thank you for sharing your expertise and for being such an integral part of our webinar. Your contribution has made a significant impact, and we are truly grateful for the knowledge and inspiration you have imparted to us. We look forward for more future collaboration with you. Thank you very much, sir. थैंक
Okay,
यू सर सर
thank you for
बहुत
all.
बहुत शुक्रिया सर आप हमारे वेबिनार में आए सर इसके लिए बहुत बहुत शुक्रिया सर आपको सर और
बहुत बहुत
फ्यूचर में
धन्यवाद.
फिर से हम आपके और भी बेटर वेबिनार हम कराएंगे हम आगे हम एफडीपी भी कराएंगे और इंटरनेशनल कॉन्फ्रेंस भी कराएंगे उसमें भी हम आपको इनवाइट करेंगे क्योंकि आज के वेबिनार में हम लोग काफी अच्छा हम सबको हमें जो भी स्टूडेंट्स का जो भी हमें जो मिला है व्यूज मिला है वो काफी अच्छा है उन्होंने काफी अच्छा हमारे पास भी अभी कॉल आया कि सर ने बहुत ही अच्छा पढ़ाया है बहुत अच्छा बताया है थैंक यू सर थैंक यू वेरी मच
Okay, thank you. Jai
थैंक
Shri
यू सर
Krish. Okay.
Thank you all the delegates and dear students. Hopefully we'll be meeting again in our next webinar. Thank you students. Thank you all the delegates.